Hi and welcome back. So in this video we explore the second concept we introduced in the beginning of the chapter, and that is the concept of expected present discounted value. So to motivate our discussion, let's return to the example of the manager considering whether or not to buy a new machine we had in the beginning of the chapter. So when the manager considers whether or not to buy the machine, on the one hand, they have to consider that buying and installing the machine involves a cost today. On the other hand, the machine allows for higher production, higher sales, and higher profits in the future. So the question facing the manager is whether the value of this expected profits is higher than the cost of buying and installing the machine today. So this is where the concept of expected present discounted value comes in handy. So the expected present discounted value of a sequence of future payment is the value today of this expected sequence of payment. So how this works is that once the manager has computed the expected present discounted value of the sequence of profits, their problem becomes more simple. So they have to compare two numbers. One, the expected present discounted value they have calculated, and two, the initial cost they could have incurred when installing the new machine. So if the value exceeds the cost, they then should go ahead and buy the machine. But if it does not, they should not. So as for the interest rate, the practical problem is that expected present discounted values are not directly observable. They must be constructed from information on the sequence of expected payments and expected interest rate. So this is the direction we take in constructing our analysis of the present discounted value in this session. So when computing the expected present discounted value, we need to go back to the introduction of the nominal interest rate and real interest rate we had in the previous session or in the previous videos. So what we argued is that if the 1 year nominal interest rate is given by IT, this would mean that lending R1 this year implies getting back 1 plus the IT next year in rent. So in this sense, it also means that borrowing R1 this year implies paying back this amount next year. So now that that is established, for the purpose of the present discounted value, what we need to ask is that how much is R1 next year worth today? So in other words, if we know that if you borrow R1, this is the amount of money you pay next year. But if you wanted to get R1 back next year, how much would you have to borrow out this year? In other words, how much is R1 next year worth today? So this is simple. So if we know that if you borrow R1 this year, you pay 1 plus the interest rate next year. Then if you wanted to get R1 next year, you simply discount the R1 by its discount value, or by the rate or the amount you would have paid next year had you borrowed R1 today. So in essence, you're basically reversing the equation. So this means that R1 next year is worth 1 over 1 plus the interest rate this year, such that if you lend 1 over 1 divided by the interest rate, or 1 divided by 1 plus the interest rate this year, you would get that amount plus the amount that is earned by it next year, which is equals to 100 next year. So this means that 1 over 1 plus interest rate is therefore the expected present discounted value of R1 next year, such that if you borrow this amount, you'll be paid R1. You will pay out R1 next year. And if you borrow out this amount, you will get R1 next year. So the word present comes from the fact that we are looking at the value of payment next year in terms of rents today. So we're looking at the present rents of something that is fully accumulating next year or will be paid out next year. So the word discounted comes from the fact that the value next year is discounted with the discount factor of 1 over 1 plus the interest rate, which is our discount factor. So one important note from this is that, one, because nominal interest rate is always positive, the discount factor is always less than 1. So 1 rand next year is worth less than 1 rand today. So this is understandable, because for you to earn the 1 rand with an interest, or rather to earn a total of 1 rand after an interest next year, you need to borrow less than, or rather you need to borrow out or lend out less than 1 rand this year. And two is that the higher the nominal interest rate, the lower the value today of the 1 rand received next year. So what this means is that if the interest rate is low, then or rather, if the nominal interest rate is high, then the amount you need to borrow to get 1 rand to next year is basically less. So the value of 1 rand today is very low if the interest rate is high. So we use the same logic to get the value today of 1 rand received in 2 years. So meaning that borrowing 1 rand this year requires paying 1 plus the interest rate into 1 plus the interest rate of the year after. So first you look at the interest rate that we're holding this year, and you also, because it's over 2 years, you also get the 1 plus the interest rate of next year, which is rands in 2 years. So the present discounted value of 1 rand in 2 years is now 1 divided by the discounted 1 rand, or rather 1 rand plus the interest rate of both this year and next year, because now you're not only looking at one interest rate, but you're also looking at interest rate or an amount earned with an interest rate over 2 years. So our analysis or narrative or formulation of the discount factor is represented graphically here. So the first argument we had is that 1 rand earns 1 plus the interest rate next year. So to get our discount factor 1 rand, the cost of 1 rand today, we reverse the analysis such that we divide what you would have earned of 1 rand, or divide 1 by what you would have earned next year if you borrowed 1 rand today. Then we use the same narrative to say, if you borrowed 1 rand today, how much would you pay in 2 years? You'd pay 1 rand plus the interest rate of this year and next year, or next year and the year after, for 2 years. And we use the same analysis to reverse the narrative. Then to say, to get 1 rand in 2 years, you need to borrow 1 divided by what you would have earned if you borrowed 1 rand today or this year. So now that you've gone through these steps, it is now easy to derive the present discounted value of the case where both payments and interest rate can change over time. So to do so, consider a sequence of payment in rand starting today and continuing into the future. So we assume for the moment that both future payment and future interest rate are known with certainty. So we know how much payments are made over the years and how much is the interest rate. So we denote the payment by RZT or rand ZT. So the payment next year, so this is the future payment by that, such that the payment next year is RZT plus 1. The plus 1 showing the number of the representative of next year. And the payment in 2 years such that it's R plus ZT plus 2, and so on and so forth. So the present discounted value of the sequence of payment, that is the value today, rather the value in today's rands of the sequence of payment, which we shall call RVT, is given by this formula. So this formula shows that the value today of a sequence of payments in rands is equals to the different payments, or rather the different discounted payments made over time. So as you can see, apart from the first payment, all payments in the future are or is multiplied by its discounted factor. So this one is multiplied by its discounted factor of the interest rate over 1 year, and the payment of the second year or year 2 is discounted by the discount factor over 2 years. And one thing you should realize is that the more distance the payment, the smaller the discount factor, and therefore the smaller today's value of the distance payment. This basically means that future payments are discounted more heavily. so the present discounted value is lower. Or in other words, this discount factor is lower than this one. So the first discount factor is higher than this one. This is simply because this payment is made over an extended time, meaning that smaller payments can be made on it than a payment that is made in a close by time. Okay, so while this may be clear, the problem we have with our analysis is that we assume that future payments and future interest rates are known with certainty. But actually, decisions, however, have to be based on expectations of future payments rather than an actual value of the payments, meaning that what we expect the payments to be in the future. So in our example, in the beginning, the manager cannot be sure of how much profit the new machine will actually bring, or does they know what interest will be in the future. So they have to deal with expectation. So the best that they can do is to get the most accurate forecast. Then they can compute the expected present discounted value of the profit based on this forecast. So how do we compute the expected present discounted value when the future payment and interest rate are uncertain? So basically, the same way which we have just done is the same way we use to compute the present discounted value using expectation. We simply replace the known future payment and the known interest rate with the expected future payment and expected interest rate. So formally, we denote our expected our expected payment next year by the expectation here with the E to denote the expectation. We also do the same for the expected payment in 2 years, and we do so for every year afterwards. So similarly, we denote the expected 1-year nominal interest rate next year by a value that shows an expectation as shown in our interest rate of our expected interest rate next year. So as you can see in our new equation, the expected payment next year is unknown, but because we know the interest rate currently, there is no expectation in the interest rate, and there is an expectation of the interest rate in 2 years because the interest rate will change over time, and the sequence of payments after the one that we start off. So the first one, we know the first payment, but the sequence of payments thereafter, which are discounted, are based on expectations than actual payments. So in essence, equation 14.6 shows us the expected present discounted value of an expected sequence of payments in the future. So using the present value, for example, equation 14.6 has two important implications. So one, the present value depends positively on today's actual payment and the expected future payment, such that an increase in either RZ, this one, or an increase in this one, the expected an increase in either today's RZ or the future RZ, future payment, leads to an increase in the present value, which is this. So the increase in one and that, or even that, will impact that positive. The second implication is that the present value depends negatively on current and expected future interest rate, such that an increase in either interest rate I or future expected interest rate leads to a decrease in the present value. This is because the fact that these interest rates are below the division, it suggests that their increase will basically reduce the total amount of payments and subsequently the total amount of the discount value or the discounted value of payments, which is represented by RV. Hence, we say the present value depends negatively on the current and expected future interest rate. All right, so we'll end here for now. Then in the next video, we're going to look at the different instances when there's a change in the sequence of payment or interest rate over time. All right, thank you.